Well, I like to say what amazing presentations thus far. Um, I did not know that my fellow peers are so amazing and so smart. So thank you for presenting. I'm so honored to be here right now among all of you guys. So my name is Char'Mane Robinson. I am a McNair and UR Scholar currently attending here at CSUMB, majoring in environmental science. I'm also a NOAA Educational Partnership Scholarship recipient. So last summer, I had the amazing opportunity to do my summer internship at the NOAA headquarters in Silver Spring, Maryland, and I'm honored today to present to you my research. So this is a zoom-in map of Cocos Lagoon, Guam. And I'll be referring to this map throughout my presentation today. So how many of you guys are familiar with Guam by chance? Okay, a few people. That's really good. So Cocos Lagoon is an important coral reef habitat and fishing site. But more importantly, it's an essential food resource. The local residents highly depend on the fish population from Cocos Lagoon to feed themselves and their families. In 1944, a U.S. Coast Guard navigation site was built on Cocos Island, and during that time it's suspected that hazardous waste materials, in particular PCBs, were dumped on and off the island, exposing the surrounding water, sediment, fish species, and human beings to this hazardous material. Currently, the local residents are concerned about the environmental contaminants that have been found in Cocos Lagoon and how it could be contaminating their fish species. So, what are PCBs? PCBs are man-made organic chemicals usually found in transformers, capillars, and electrical parts. They're exposed to the environment when they're either dumped or buried near open water with marine aquatic life. Once in the environment, they become extremely persistent, and fish species can begin to take up the PCBs. Human beings can also accumulate PCBs when they ingest these contaminated fish as well. In 1996, the EPA did a study linking PCBs to causing adverse health effects such as cancer, immune deficiencies, and birth defects found in both the animals and humans. So in 2005, the U.S. Coast Guard did an investigation and found high levels of PCBs around Cocos Island. However, they did not investigate the entire lagoon. Local residents were still concerned, so in May 2015, NOAA scientists were sent out to collect both sediment and fish tooth examples, this time from the entire lagoon, that were later brought back to the lab and analyzed for 190 chemical contaminants, including 82 PCB carcinogens. For my part of this project, I had three main objectives. One, to conduct statistical analysis on both the sediment and fish tissue examples brought back, to develop my results into charts and tables that later be incorporated into future NOAA reports and manuscripts, and that these reports will be used by local agencies and the public to help assess the health risks associated with the current contaminants found in Cocos Lagoon. For my methods, I use ArcGIS to relate the PCB concentrations to the EPA screening values. In addition, I also use statistical analysis tools such as JUMP, Assess Product, and R. For my first bar plot, unfortunately, a little bit has been cut off, but we can still get the gist of it. So for the x-axis, we see the concentrations, and on the y-axis, we see the example locations. This bar graph is displaying the PCB concentrations found in both the sediment and fish tissues. So pink is the sediment and blue is the fish tissue. As you can see, the sediment is fairly low, in fact, less than or equal to 1.20 nanograms per gram. This is because of the unique sediment composition found in Cocos Lagoon. The sediment composition found in Cocos Lagoon is 90% sand and 10% gravel, soot, and clay. Sand has a relatively small surface area, which makes it hard for the PCBs to attach or bond to. So essentially, the sediment just naturally filters out all the PCBs. However, we do see PCBs accumulating in the fish tissue. So the US EPA developed the EPA screening values to assess the risk of humans eating contaminated fish. And how it works is that human beings are split into two categories. One would be subsistence fishers, people like the local residents of Cocos Lagoon who eat fish on a highly daily basis. Because they're eating the contaminated fish or is being exposed to it more frequently, they have a lower screening value of 2.45 nanograms per gram. There's also recreational, people like you and I who probably eat fish maybe once a month. Because we're eating it less frequently, we have a higher screening value of 20 grams per gram. So finally, I was able to use ArcGIS to relate all my results into one cohesive map, and let's break this down. So on the top left corner, you can see these are the list of species that were found on Cocos Lagoon, and there is the letter code that I'll be referring to on my map. On the other side, to the right, you can see that the red represents PCB concentrations found above the recreational screening values, which means that these concentrations are harm to both groups of fish, so subsistence fishers and both recreational fishers. Well, yellow means it's moderately high, so it means it will only cause potential harm to subsistence fishers, people like local residents who eat it on a daily basis. And green means that it will cause no harm at all. As you can see, the highest concentrations, the red, are found right around Cocos Island, again where the original contamination site occurred. However, I want to be scientifically sound, and I wanted to make sure that they're statistically different. So I've conducted a non-parametrical causation test. I split the lagoon into two groups. The first group being the area within this red circle versus the rest of the lagoon. And I found a p-value that suggests that yes, the concentrations of PCBs around Cocos Island are significantly higher than throughout the lagoon. But you see this yellow right here, this EM, that means it's moderately high PCB concentration. That's because this particular fish is the honeycomb grouper. It's an active mobile fish, which means it likes to swim around a lot. It is also found at the highest abundance compared to all the other fish species found on Cocos Lagoon. I believe because it's an active mobile fish and is found on the highest abundance, that it is swimming around Cocos Island, picking up the PCBs, and then carrying it out the lagoon, and that's why we're seeing moderately high values throughout the lagoon. So based on my results, the lagoon has been currently set down, and no fishing is occurring as of right now. So although this might be really fantastic as a scientist, my results include something and action was taken, it's not really beneficial for the local residents, however. Right now, there's a current ongoing debate because the local residents highly depend on the fish populations to feed themselves and their family, and we have unfortunately taken that away from them because of the high PCB concentrations found. So there right now is an ongoing debate. These are the stratons where we conducted our sample collecting, and right here in this red corner is the area that we did not sample. Right now, the local residents are strongly pushing for this area to be open so that way they can do some fishing. However, NOAA is concerned about it because we did not collect any samples out there, so we don't know what PCBs or what environmental contaminants are out there in this area. So I encourage you all to go to the NOAA website and Google search Cocos Lagoon so you can read more about this ongoing debate. So for my next step in this project, I will be publicizing my results into future NOAA reports and journal articles this upcoming fall. In addition, NOAA scientists are going to be sent out this upcoming summer to conduct more monitoring and assessments. So they're going to collect more fish tissue samples and also in addition do water quality testing. Based on my results, we know that the PCB is not accumulating in the sediment. However, PCB is somehow accumulating in the water. It's there. We're not sure how yet, so we're going to do water quality testing to figure that out. It doesn't happen very often that an undergrad such as myself not only gets to work on such an amazing project, but a project that had real-world implications. I'm extremely honored and proud of the fact that the work I did will help contribute towards cleaning up Cocos Lagoon, so that way the local residents be able to fish again in peace and not have to worry about any environmental contaminants being in their foods. Thank you so much for listening to my presentation, and as of right now, I'd like to open up for any questions. Yes.
So what do you think about especially subsistence people fishing and eating because presumably they may not have the same economic ability to provide their own food, depending on what their jobs are. It's more expensive on the islands. So there's kind of a social justice issue. And how do you feel about that, whether they should be able to fish there or not?
You're absolutely right. This is a social injustice issue. I think a lot of times as scientists, we don't like to go down that route. We just like to say, these are my results and kind of back away from it. But it's important that we do make those connections because we do have the power to really change things. So I believe that the local residents should not eat there because we still need to do monitoring and assessing. It's better to be safe than to be sorry. So I suggest that they don't fish as of right now and really wait into the summer where we done water quality testing to see what's really going on and get a better picture and understanding of the situation happening in Cocos Lagoon. Yes. Oh, sorry.
Thank you so much. It's so fascinating. I'm learning so much about it. On the theme of social justice, could you tell us the cause of the PCB contaminant? Where does that come from? And if we can take a look at the cause, the root cause, then perhaps we can, find solutions to help these fisher people who are so dependent on their livelihoods.
So the cause was the U.S. Coast Guard navigation station built on Cocos Island. During that time, it was built back in 1944. So during that time, we didn't have the environmental regulations that we had today. So during that time, a lot of the hazardous waste were dumped on and off the island. So that is the source of contamination. And so the U.S. Coast Guard did do a study and found high levels of PCBs around Cocos Island. And my results show that there's still higher results of PCBs around Cocos Island. Although the problem is that the PCBs have now spread. If you look back at my map, sorry, there's a delay with the clicker. Okay, here we go. So if you look back at my map, we can see how the highest PCBs were found right around Cocos Island, and we can see how it's spreading because of the fish species and water and natural causes. So the task right now is to see where is it accumulating in the water. That's why it's so important to do water quality testing, so we can help pinpoint where the highest contamination is occurring, and we can help clean up that area because it's expensive to try to clean up this whole lagoon. That's not practical. But we can pinpoint where is the highest accumulation in the water. Hopefully we can make statistic differences and we can help clean it up. I hope that answered your question. Yes.
Have there been adverse health effects to the people living in that area already?
Yes, I was really happy you said that. I was waiting for that question. So, yes. So, they have found that there has been a higher increase in cancer and also miscarriage found along the villagers. However, we can't conclude that it's because of the PCBs because there's also natural causes of tobacco. What are they eating? Do they have access to healthcare? So we can't conclude it's because of the PCBs, but we do know from that time where the PCB has been exposed to Cocos Lagoon, there has been statistically higher adverse health effects such as cancer found in the local residents. Yes.
I'm curious, is there any feasible way to say you can fish this area except the EM fish? Is that possible?
Yes.
It seems that other fish are safe in a certain zone.
Yes. So I would suggest is we start tagging the fish so that way we know which fish have the highest accumulation. It's hard to say which area we should open up because potentially fish like to roam around, they like to move. Potentially a fish of high PCBs could move into one of the lower grade areas. So that's why I believe it's important to tag them so we can monitor where they're going and when and where. We can help assess this area is okay to eat compared to this area is not okay because the higher PCB concentration fish that were tagged, they like to accumulate in this area here.
And is that a practice they can do where they say we can fish this species but not this species?
Yes, that is a standardized practice that the NOAA uses. Yes, you had your hand up.
All 8 species are food sources that are on the top left list.
Yes, all these fish species. Excuse me for a moment. Wait. Yes. So yes, this is a image along with the scientific name and common name of all the species that were example for this project and that are local. So all the local residents do eat these. Yes.
And that picture just answered my other question.
Yes.
There aren't many bottom-dwelling fish in that group. They all look like coral reef.
Yes, exactly. They're,
Probably herbivore.
yes, most of them are benthic figures. Victors.
Thanks.
Yes.
Thank you, Char'Mane.
Thank you.